So here, the given angle measurement is a variable. So we will consider the angle measurement as u, which is a differentiable function of x. Understood, the u, the angle measurement, is a variable. So we have that the derivative of the function cosine. So we have derivative of cosine u with respect to x is negative sine of u, and then times the derivative of the u with respect to x. For the sine function u, the derivative is cosine u times the derivative of the u with respect to x. For the tangent function u, the derivative is secant square u times the derivative of the u with respect to x. For the function cotangent u, the derivative is negative cosecant square u times the derivative of the u with respect to x. For the function secant u, the derivative secant u times the tangent u times the derivative of u with respect to x. And for the function cosecant u, the derivative is negative cosecant u cotangent u times the derivative of u with respect to x. Let us discuss some examples. First function is y equal to 2 sine 3x squared. So the given angle measurement here is the 3x squared. Now since we have to multiply the derivative of the angle u, so we might as well we have to look for the derivative of the u. So by means of power, this is 6x. Therefore, the derivative of the function y as derivative of y with respect to x or y prime is now the coefficient as 2, and then derivative of sine 3x squared is cosine 3x squared times the derivative of u, which is 6x. We can simplify our answer as the y prime is equal to 12x because we have to multiply the 6x by 2, and then cosine of u as cosine 3x squared. For number 2, we have y equal to cosine of 1 minus x squared. So our u here, the angle measurement is 1 minus x squared. And since we need to multiply by the du, then we can find the derivative of u first with respect to x. So the derivative is negative 2x. Then, the derivative of y, which is y prime, is negative sine of 1 minus x squared times the du as negative 2x. So simplifying our answer now as negative 2x times negative is positive 2x, and then sine function of 1 minus x squared. For our number 3 example, y is equal to tangent of 4x plus 3. So our u here, the angle measurement u is 4x plus 3. And the derivative of this u with respect to x is 4. Then, the derivative of the function y as y prime is, derivative of tangent is secant square of 4x plus 3 times 4. Or simply as 4 times the secant square 4x plus 3 as our y prime. For number 4 example, y equal to sine cube of 3x. This is actually by means of power, where the sine cube of 3x can be also expressed as sine 3x raised to 3. So this is an example of power derivative, wherein our u is the sine 3x. Then, since we need to multiply by the du, even it is by means of power rule, therefore we can have to look first the derivative of sine 3x. And the derivative of sine 3x is cosine 3x times derivative of 3x as 3. Therefore, the derivative of the function y as y prime is now by means of power rule, wherein we can bring down the power 3 and then less 1 from the exponent, so this is sine square, and then multiplied by the derivative of u, which is cosine 3x times 3. And then simplifying, we can multiply the 3 and 3, so we have 9. And then we have sine square of 3x and cosine of 3x. This is our answer to that function. For number 5, we have y equal to cosine square x minus sine square x. This can also be simplified as y equal to cosine 2x because from the identity that cosine square x minus sine square x is equal to cosine 2x. So we can simplify it by using that identity. Therefore, the angle here, which is our u, is 2x. And the derivative of that u with respect to x is 2. Then, the derivative of the y as y prime is now, derivative of cosine is negative sine u. So, we have negative sine 2x times the derivative of u as 2. So, our answer is negative 2 sine x. Now, if you want to use the power rule without using this identity, you can also apply that, but it has a longer solution. So the y prime here by power, this is bring down 2 and then cosine of x, and then derivative of cosine is negative sine x. On the second term, we can bring down the 2 here, minus 1 from the exponent, and then derivative of sine is cosine. Then this is now negative 2 sine x, negative 2 sine x, cosine x, wherein we can combine, we can add as negative 4 sine x, cosine x, or we can factor the negative 2, so negative 2 times 2 sine x, cosine x. Again, this is another identity that the 2 sine x, cosine x is an identity of sine function for the double angle. So this can also be expressed as sine 2x, then multiplied by the coefficient of negative 2. As you can see here, they are the same. You will arrive to the same final answer, but on this second method, we also use an identity. For our number 6 example, we have y equal to cosine to the 4th x minus sine to the 4th x over cosine x minus sine x. Now, we will use an algebraic solution here because the numerator part can be factored as cosine squared x minus sine squared x times cosine squared x plus sine squared x. And then we can reduce the cosine squared x minus sine squared. And then the cosine squared x plus sine squared x is another identity which is equal to 1. This cosine squared x minus sine squared x can be factored as cosine x minus sine x and then cosine x plus sine x. We can reduce now this quantity, cosine x minus sine x. And then remaining here, we have cosine x plus sine x, and this is equal to 1 as an identity. So we can simplify now our function as y equal to cosine x plus sine x. Then we can now find the derivative of this. So the derivative as y prime is, derivative of cosine is negative sine x, and derivative of sine is cosine x. We can simplify by make it positive as the first term. So we have cosine x minus sine x.